Okay, right, so here's a worked example. What I might try and do is links to some videos, but if you check on YouTube, histogram questions or exam solutions, maybe I'll put some links up on exam solutions for other ones you can watch. But yeah, okay, so I'm looking at page 52, question 6. This is exercise 3D from a textbook, which is also on the classroom for today. Okay, so write down the class boundaries for 13 to 14. Now this is what I was saying about continuous data. So continuous data. You don't have any gaps, right? So the 13 to 14 will actually, so at the moment we've got 10 to 12, 13 to 14, and 15 to 17, and 18 to 25. But there are gaps. What I mean by gaps, there are gaps in here. They need to be the same number. So we just close them equally. So it'd be 12.5 to 14.5, and then it'd be 14.5 to 17.5, and 17.5 to 25.5. Actually, and 9.5. We can, if we're opening this one up, we should also close this one. Okay, so that's the answer then, isn't it? 5 to 14.5. Histogram was drawn, and the bar at 14 had a width of 4. I way to do this is draw it out. Remember, it's all about ratio. The whole question is about ratio, with an I, ratio. So the bar representing 12.5 to 14.5 had a height of 4. So it had a width of height of 6. And I'm going to the area on that area then is 24. Okay, so it's got an area of 24. Now we know between 12 and, I'll find a different colour. Between 12 and 14, that has got a width of 2, doesn't it? Okay, so what's it saying? For the bar representing 15 to 17, which is this one, we want the width and the height. Okay, fine. Well, it's got an area of 24, and it's got a frequency from the table. So I have the frequencies down here. It's 6, 24, 18, and 12, isn't it? Of a frequency of 24, and it's got an area of 24. So the ratio, remember, we've got frequency is equal to k times the area. All right, so we've got 24 is equal to k times 24. So here k is equal to 1. So that here, just like in GCSE, area is equal to frequency in this example because we've got k equals 1. Okay, so there we go. I think we're good to go. And also the other place where we've got ratio is it looks like in the histogram, the width is twice the distance between the numbers. So if we go now here, we've been asked about the 15 to 17 one, which is actually, remember, 14.5 to 17.5. Again, we need to change the interval so there are no gaps. Now that's got a distance of 3, hasn't it? So the bar chart, sorry, not bar chart, the histogram is going to have a bar of, so to go from here up to here, what do we do? Look at this one, the ratio is times 2, so we're times 2. Now have a width of 6. Now what's the area going to be? The area is going to be the same as the frequency because k is equal to 1. So the frequency is 18, so that means the area will be 18. We've got a width of 6. I'm going to write that down there, width of 6. So what's the height going to be? Width of 6, area of 18, so the height is going to be 18 divided by 6, which is 3. So there we go. And that is that. So in summary, what have we done? It's all about ratio. I like drawing representation of the bars because then you can see everything. We've closed the gaps because it's continuous data. We've worked out the constant of proportionality, which here happens to be 1. Fine. And then again, we've drawn a new bar, make sure we close the gaps, and then just run through everything with ratio. It's all about ratio. Okay.